We apply it to the external interface. Access list 105, deny, permit, 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 permit. This is all ICMP that we permit. Now, again, going back, if we need to permit specific services, they would go before those deny statements under TCP and UDP. They have to, because it goes in sequence. It goes in sequence. So, if the packet that comes in is TCP, it gets dropped. If it comes in as UDP, it gets dropped. But if we have access list rules before those two that permit specifics, it will be allowed. They will be allowed. And then these are different permits for ICMP, for example. All right. That kind of finishes up the ICMP, and it'll deny any other type of ICMP flag. Then you apply it to the inbound interface. In this case, for example, we'd be applying it right here. Okay? And then we would put in IP inspect my firewall out. What inspection is going to do is, if I have traffic that goes outbound from my PCs, and it's established, that connection coming back in is going to be allowed. It's going to be allowed, regardless of what I have up there on that access list. Now, the CBAC configuration will allow only limited ICMP information with those access list rules that we saw. The inspection rule filter 1 will allow internal users to start outbound World Wide Web sessions via HTTP and track the sessions opening return points in the static extended access list. This is also true for FTP and SMTP. Okay? Okay? To change inspection rules, you can easily add or delete them one at a time. If at any point you want to check the configuration, you can simply do the show IP inspect all, and it'll bring up details. The all parameter will display information such as current configuration of inspection as well as current sessions traversing the firewall, which is very important. Okay, you can look at your state information from individual PCs. Great if you're running a small network and you got about 5, 6, 7, 8, 20 PCs. If you're running a huge network, you need to find some automated tools that will help you manage that.
If you show your configuration for the entire router, will it show the inspection configuration on there?
It will show the inspection configuration. It will not show you the state information, the current state information running through the firewall. That's where you have to do the show IP inspect all. It will give you that information as a snapshot in time. Okay? Simple installing iOS firewall software does not fully ensure a secure network. The router and CBAC must be configured properly to secure the private network from unwanted access. And with this in mind, you'll want to apply other well-known protections to the firewall. Among these are broadcast protections, anti-spoofing measures, and here's just a couple of examples. Okay? On the interface, no IP directed broadcast, no ICMP redirect, no IP redirect. Globally, no service finger, no CDP run. Alright? And no IP source route on your interface. Okay? That will prevent typical malformed packets from being allowed through the receive buffer on the interface. Okay? Because with the packet generator, I can specifically formulate IP packets for my own purposes. When we get later on towards Lab 5 and you start working with Metasploit and Armitage, that does that on the fly for you. It's already pre-coded, if you will. Okay? But that's all it's doing. The prescripts that are in Metasploit is nothing more than an automated automated packet generator that pre-programs different flags within the TCP, UDP, or IDP, or ICMP, or IP header. Alright, don't consider this to be a complete list of precautions. This is merely a sample of the types of settings to implement for a secure network environment. Check the support website, check at Cisco. Be sure to look at other commonly known websites through the Department of Homeland Security, NIST, here. Carnegie Mellon has a great website. Their search center is phenomenal. But you need to constantly stay up on vulnerability. Not just to infrastructure equipment, but also to operating systems as well. Okay? Don't think that once you're done with this class and you go out into the field, you know all there is. No. Guess what? Stuff is going to change tomorrow. And you need to stay on top of it. Summarizing, although iOS firewall provides a higher level of security than the standard access list approach that you can put in, like other firewalls, it shouldn't be considered invulnerable. A determined hacker may be able to find holes in the most secure systems. I've demonstrated a strong security feature of CBAC, but you may want to consider a dual firewall approach if your security needs are in high demand. What hackers will try to do sometimes is if they see a firewall, they will either try to breach that firewall, knock that firewall out momentarily, bypass that firewall. If you have a second firewall in parallel with it, if that first firewall goes down, the second firewall will maintain the security while the primary firewall recovers. It's called a failover system. Some of the advanced features of iOS, you can do HTTP inspection and email inspection. It's limited, it's better than nothing. You set that up with IP inspect name, whatever you're going to name it, and you can do SMTP or eSMTP. You can reference that in the CBAC section of your book. You can do a firewall ACL bypass. So you can tell the certain IPs that, oh, you know what, I trust you. You can bypass my firewall feature set. Why you want to do that, I don't know, but you could. Transparent iOS firewall at layer 2. Your router will then act as a bridge instead of a router. Okay? Same thing can be done in an ASA called transparent mode. Okay? Or what we call a stealth firewall, or bump on the wire. Because you can't see it. If you can't see it, it becomes very hard to knock out. And then there's virtual reassembly for both frame relay and MPLS. It's a little bit of an advanced topic that we're not going to go into. Inspection of router generated traffic. You can inspect traffic that is generated by your router. Now, what would that be? Could be dynamic routing protocol traffic. It could be traffic that is in response to queries on like your HTTP engine if you have to run your web engine. Zone-based policy firewall, or ZFW. This is router virtualization. I'm not going to go very deeply into it. There's a lengthy section on how to set this up. The thing that I tell clients and students alike is if you have to go and you have to virtualize your router and make multiple routers within a single routing device, all right, this is dozens of lines of code. In the ASA firewall, it's 2. Buy a firewall. It's easier to manage. It's worth the money. Okay? But it does have limited URL filtering and DOS mitigation. Okay? With the zone-based policy, you have to define your zones. The define the class, build class maps. You have to do a lot of object-oriented programming. Define a policy map to apply the action to the traffic in a class map. Apply a policy map to a zone pair. Assign interfaces to the zones. It's a lot of programming. Okay? In the ASA, security level 50. Security level 20. Okay? That defines your zones and your trust between interfaces. Done. Couple of notes. I'm done. I still got done 30 minutes before the last class. You guys don't ever ask any questions. Except for the gentleman in the back. Thank you very much. Any questions? You guys are just tired. It's late. I understand. Okay, I get it. Okay. Last but not least, let's go over Lab 2. We'll go over Lab 2 a little bit more in depth on Tuesday. But in general, instead of one router, we're going to set up 3. Yay! Okay, these are the switches in GNS3 that you can set up. You connect everything into them. Create a network, OSPF like we did before. Except you're going to have 2 areas, not 1 area. And you're going to have EIGRP. The trick here is you're going to have to do some redistribution of routing protocols within R2. I'll go over that on Tuesday. Alright? You have 2 networks. You have a workstation network and a server network. Okay? This would be your inside network basically. This would basically be like a demilitarized zone or DMZ. Okay? Dot 4 is going to be an Active Directory server that you're going to make in a VM. So if you want to work ahead, right, or if you have your VM from CIS 347 that we did in Lab 4 in that class, you can pull that sucker up and use it for this lab. Give you a little bit of a leg up and save you some time. Otherwise, you got to build a Windows 2003 server. Oh yeah, I know, like we haven't done that before. All right. So IP the routers according to the diagram. Ensure that you give the proper host name. It's very important that you read through this. It's a couple of steps that I try to trip you up a little bit. Okay? So it's very important you read through it before you just start plugging away. Create the routing protocol domains according to the topology. I'll talk a little bit about that more on Tuesday. Block any routing of RFC, that should be 1918, not 1921. 1918 networks. Read number 4. Before you start IP addressing everything, I change your subnet on you from a /25 to a /29. I will be looking at your subnet masks to see that you got number 4 correct. Create NAT as follows. Now on number 5, you can see that you have all these servers on the 192.168.50 network. You need to NAT them, statically NAT them, to these public IPs. Here's the trick of question number 5. You've got to figure out which router to do that on. R1, R2, or R3. Here's a hint. There's no one right answer. You can do this a couple of different ways. Alright? Either way is correct. So if you're working in your study groups, before you start tearing each other apart and arguing, they should do it this way, no, you should do it this way, you should do it, no. There's a couple different ways you can do it. Alright? Create and overload a port address translation and tie that to R1 for your workstations on 172.21.0.24. That's obviously your PAT is going to go here on R1. And you're going to tie it to that interface. And this can be an Ethernet interface. You don't have to put a cloud in there, as long as you IP this. That's all I'm looking for. Alright, like I said, number 7, create a DHCP pool on R3 for that network, and you're going to exclude 1 through 25. 192.168.50.4 is your Active Directory server with the following credentials. Your administrator needs to have a password change me. Create an ACS box on 50.10 and tie it to your AD. Okay? A couple different ways you can do this. You can create 2 VMs, or honestly, if you create 1 VM and have it all in one box, I'll show you how to do that on Tuesday. I'm gonna change up this so it's a little bit more clear before Tuesday. I apologize for that. You'll create an account in your AD box called John Doe. See, all you do is create a user. Now, you're going to use AAA commands to ensure that R1, R2, and R3 authenticate to the ACS server so that when John Doe tries to log into them, it works. Create an access list on R1. Remember that you natted previously, right here. And set up all these rules in your ACL. Only 6 rules. Not that bad. Now, I do need a screen, along with your config files of R1, R2, and R3, I do need to have some screenshots of your ACS server. Okay? In that VM. Seeing how that you have that set up. Okay? And last but not least, you're going to set up OSPF to do area authentication with MD5, a key of Cisco, a shared key of Cisco, so that R1, R2, and R3 send all of their OSPF traffic, all their multicast traffic, okay, all their area information encrypted. That's very important when you get into network security of dynamic routing protocols, because if I can guess your network and I can plug in somewhere and I can participate in your dynamic routing protocol and you're not authenticating in any way, shape, or form, I can get your routing table. If I can get your routing table, I can corrupt your routing table. If I can corrupt your routing table, I can crush your network. It's very important. This is one of the things that I see a lot of in large networks. They don't do any form of dynamic routing protocol encryption at all. It's a key concept that you need to have for network security, okay, to be effective. Right? Case in point, I have a couple of engineers. I'm really going to tout graduates of Cal Poly here. A couple of network engineers where I work. And I heard them complain and moan and groan and whine and gripe about this one customer. How difficult this customer was, what a pain in the butt this customer was. And once, as the support manager, I got the information from the account manager, and I talked to this customer. And then I found out what he was doing, and all he was doing was had a really good secure practice. He had a really tight VPN policy. He didn't allow anybody into his network that didn't need to be into his network. Right? He was just practicing good security. I can work with that. That's not a problem. You know? You don't want to discourage that. You don't. want to work with it, not against it, not around it. Okay? Once I had found this out, I kind of took these other two engineers that were kind of being a problem off of that project, and I have two Cal Poly alums that work for me. I put them on it. They got it. They work with the customer and they work through the issues, right? And they work through the problem, right? They carry themselves in a professional manner, and you know, they understood the reason behind this customer's security phobias, I guess you would say. Because I carry the same phobias, so we got along really well. All right, so I'm going to leave you with that tonight. We'll go in depth more so on